Hey, Rodrigo and Nicole. Glad you could make it. Are you able to see this blank spreadsheet here with rows and columns and stuff? Yeah, cool.
Yes.
Awesome. Wait for a few more minutes and then we'll get going. Today should be relatively quick. What I would suggest is that the way that you approach this lecture is to watch it and have, if you can, if you have enough screen space, have the document, the exercise itself open. Follow along and take notes in the document. Don't try to do everything I'm doing in the spreadsheet live, because you'll have it recorded. And so, hey, Christy. And so my suggestion is to just follow along, take some notes. I've printed this because my monitor is being finicky, so I don't have a second monitor. Otherwise, I just have this loaded on my first one. But yeah, take notes, just follow along. It is recorded, so when it comes time for you to do your own spreadsheet, you'll be able to just follow along with the recording and with your notes. So don't try to just do it all right now while I'm talking, because it's it'll just be too much. Let's see here. Okay, I'm actually going to share my whole desktop. So now you can see this right here. You can see the document too. Cool. And yeah, we're gonna talk a little bit about this notation, because I know that this can look intimidating, but it's just another set of symbols and ways of thinking about symbols, and so I'll go into it. Anybody get rain today?
We got a little in Santa Rosa,
Cool.
like a little tiny.
Yeah. Which, if you're comfortable, which part of Santa Rosa did you get rain in?
We're kind of like north east
Okay.
section.
So I live in Rincon Valley, and we did get what felt like for a little while there was actually raining. It wasn't just drizzle. But yeah, I'm glad it happened. I don't know how much it's not going to help much at all, but
Right.
something. And it's going to be cold next couple days. Hail. Yeah, it's cold. I guess there's supposed to be snow towards the tops of some of the mountains, maybe Bald Mountain, Hood, definitely St. Helena.
It actually just started raining in Petaluma again.
Right now, that's cool. Nice. Very good. Oh, I like the rain. Okay. Well, hello, Jessica. Welcome.
Hello.
So what I was saying a little bit earlier, we'll jump in. What I was saying a little bit earlier is I think the best way to absorb this information is to follow along with the Word document. I've printed mine out because my second monitor is not playing nice with my laptop. And so I need this for reference as I go through things. But hopefully what you'll be able to do is just watch this screen here, watch the spreadsheet, listen to what I have to say, follow along on the Word document, and you'll be in a good position, So, if it's possible, if you're on a laptop, and I strongly recommend being on a computer or a laptop, or something with a keyboard once it comes time to actually do the spreadsheet assignment. But for right now, I think what makes the most sense is, if you can split screen it, or, at the end of the day, take some notes and watch the spreadsheet, because that's where the action is going to be happening. Okay, so spreadsheets. Have any of you used a spreadsheet before?
Yes, but not to this extent.
Okay. Anyone else? It's okay if the answer is no. I find that this is one of those things where, yeah, not your favorite thing, right? This is definitely one of those things that, yeah, it's divisive. It's because it can be intimidating. And so my hope with these 3 exercises that we do in this class, is that with the first 2, you're going to get a solid, hopefully, basic introduction to what spreadsheets are and what they can do. And then in the 3rd exercise, you're going to get an opportunity to play a little bit more, and have a little bit more freedom, and then also to see, even at the next level, just using the stuff that you've learned in 1 and 2, how you can turn that into something that's actually, kind of powerful. And so what I would say, first of all, is that a spreadsheet, I was very lucky, and I learned spreadsheets in 7th grade. It was when I first got exposed to spreadsheets. And I don't want to say that spreadsheets changed my life, but spreadsheets are a very useful tool to know how to use. I've used them to create budgets for myself. I've used them to analyze my spending. I've used them to play out different scenarios for, how much rent would cost, and where to live, and maybe what kind of bike or what kind of car I needed to get, what kind of insurance, etc. I've really used spreadsheets for a lot of financial decisions, and I've used spreadsheets to play with numbers when I've had an interesting question, about the world, and there were some numbers available to me. And when it comes to science, I've talked to people in my office about this, and I've said, hey, I'm teaching this class, and I'm actually going to walk them through spreadsheets. We're going to spend 3 whole lecture periods on spreadsheets. It won't be the whole period, but 3 whole days. I devote 3 whole days to spreadsheets. And I said, because I don't think you could even get a job as a scientist with the state or the city or the county or even a nonprofit without having some basic competency in spreadsheets. And so my goal here by the end of this class is for you to have some very basic competency in spreadsheets, where you feel like you're in a position to do the basic stuff, to add, do arithmetic with spreadsheets, and do it efficiently, so that you're not wasting a lot of time. The big thing that is, and that efficiency is what makes spreadsheets so useful and powerful. Because really what's going on in the background here is just a calculator. It's a relatively complicated calculator, but it's just a calculator. Okay, like it's something like this that's going on in the background, right? It's your basic arithmetic stuff, and then it's got some other bells and whistles here. But this is all that's really going on in the background. What makes it powerful is the fact that you can automate and you can replicate processes. So you do a bunch of math. What we're going to do here today is we're going to do a bunch of really simple arithmetic. Use some fractions. Basically, the most complicated thing here is units. Just paying attention to your units, and then repeating that over and over and over again. But being able to just tell the computer, hey, repeat that over and over and over again, as opposed to having to go in and do it all by hand. Right? Doing it all by hand is really tedious and time consuming. So a spreadsheet really, really accelerates that process and makes it a lot more efficient. So let's jump in. The way that this exercise is motivated is essentially, this is something I did have to do in my current job. Like, one of the first things I got handed was this kind of problem. And it was expected that I knew how to do it, that I wasn't going to have any problems or need to get any help from anybody. So hopefully, again, by taking this class and absorbing some of this information, you'll put yourself in a position where you can answer questions in an interview if you ever go forward with a scientific job or something like that, where you can say, yeah, I've done some stuff in spreadsheets. So I get handed a report, right? Or the assignment says that you get handed a report, and there's some information in the report, and it just really basically has things like volumes and densities and concentrations and stuff like that. And the goal here, what you want to get out of it, is a conversion of a volume of sediment, an amount of dirt basically that's been taken out of a flood control channel, and a mass of phosphorus. Okay, so you want to go from a volume of sediment to a mass of phosphorus, and depending on the units that you're given, certain conversions are available to you. So the first thing that should stand out to you here from table 1 is that you're given a volume of sediment, a bulk density of sediment, and a phosphorus concentration. And the units here in volume, we're talking about cubic yards. So you'll see that in the spreadsheet setup right here. That's yards, YD with a 3 over it, or next to it. I got lazy. I guess I could turn this into a superscript. But it's just yards with a 3. Okay. And then pounds per cubic yard is your density. All right. And so that's reflected here in this column. Let's call, these are set up as columns, A, B, C, D, E, and so on. And there's also rows, 1, 2, 3, 4, 5, etc. And so when you set up a spreadsheet, you set it up almost always this way, where you have what are, I guess you could call, variables here up top, and you have your observations here as rows. We'll get to that in a little bit. And then you're given phosphorus concentration, and you'll notice that's way over here in column G. Okay. Why are there so many other things in between? Well, it's because you have to do these unit conversions. You have to do the arithmetic to get over here to actually use phosphorus concentration to get a mass, all right, of phosphorus over here in column H. So what are we going to do? How are we going to do this? Well, if you look at step 2, or I guess section 2 in our document here, you start to see a bunch of like fractions and, subscripts and superscripts and capital letters and stuff like that. This is just another way of representing the problem. And I want to expose you to this because this is the kind of thing that scientists have. This is kind of how scientists write. Okay, because everything needs to be sort of shorthand because there's only so much space, and it ends up looking really confusing actually, and harder to do the math if you write out volume of sediment in cubic yards. If you're taking notes or something like that, you might write that out, volume of sediment in cubic yards. But the way that that's going to get denoted in this equation for the sake of space and for clarity is V, so volume represented by V, with a subscript sed, S-E-D, just short for sediment. And that could have just been an S for sediment, okay? But just to make it easier here, it's sed. And then the superscript on V is yards cubed, cubic yards, okay? And that all that information there is summed up with just those few letters and numbers. V sub sed superscript yards cubed, okay? And all that means is volume of sediment in cubic yards, okay? So you look at this first equation here and you see this V sub sed yards cubed all over 1. Okay, and the reason that I've represented it as a fraction, as being all over 1, is because I want to make it really clear what's happening when we're doing this unit conversion, when we multiply the density. Okay, the mass in pounds of sediment per unit of volume of sediment in cubic yards. Okay, so what you will get out of that is just a mass of sediment in pounds. And the best way for me to illustrate that here in the way that it's typically, or at least the way I was taught, is that any number over 1 as a fraction is equal to itself, because that over really means divided by. Okay, so 1/2 or 1 over 2 really means 1 divided by 2. Okay, and 2 only goes into 1 half the way. You can only get half of 2 into 1. And so that's why it's equal to 1/2 or 0.5, right? So when you're converting units, we're doing something here that's actually called stoichiometry in chemistry. If you've taken chemistry, this should be actually pretty simple and straightforward. But what we're doing here is we're multiplying a volume by a density. And because of the units of density, which is just mass per unit volume, if you multiply by a volume, what you get left over is mass, because the numerator, what's on top on the left, volume of sediment, okay, over 1, the numerator there is just volume, and it's actually being divided by the same unit, by volume, okay, which is in the denominator of this density expression, which is on the right in mass over volume, okay? And because they have the same units, because they're both yards, cubic yards, and they're both representing sediment, the term cancels completely. Okay, so volume on the left is quote unquote canceled, and volume on the bottom on the right is quote unquote canceled. What that really means is that they turn into the number 1, because what you have here is volume of sediment in cubic yards divided by volume of sediment in cubic yards, and that equals 1. Okay. Anything divided by itself, it can go in 1 time, so it equals 1. And so now what you have, and all that's left is mass. Okay, all that's left is mass in pounds of sediment. Okay, so now we have pounds of sediment. That's great. But we need kilograms, because the phosphorus concentration is given in grams of phosphorus per kilogram of sediment. So now we need to convert the mass of sediment from pounds to kilograms. And the same logic applies to this next step. It's exactly, the math is exactly the same. Okay, we've got a mass, and now we're multiplying by a simple unit conversion. We have a mass in kilograms over a mass in pounds. Okay, you multiply those two by each other, and you're left over with a mass of sediment. Okay, and that's in kilograms because the pounds terms cancel. All right. Okay, well, great. Now we've got a mass of sediment in kilograms. We're going to end up here in column F. All right. And then we've got this concentration. Great. They gave us the concentration, right? They gave us grams per kilogram. So 2.63 grams of phosphorus per kilogram of sediment. So again, we're using the capital letter M to reflect mass. Okay. We have mass of sediment in kilograms on the left, divided by 1, multiplied by the mass of phosphorus in grams. And that is divided by the mass of sediment in kilograms. And so again, our mass of sediment in kilograms cancel. Okay. And what we're left with is the mass of phosphorus in grams. All right. And then, because this is the United States and we use units like yards and pounds, we're going to need to go, instead of like liters or meters or or grams, we need to convert over into pounds because that's how the regulation is written. It's written in pounds. And so we're just going to do the same thing again. This is, you'll notice this math is exactly the same. Okay, and we end up with a math. We just do a unit conversion. We multiply our mass in grams by the number of times that, you know, a gram can go into a pound, and then we have our answer. Okay, and so we need to build this math. We need to build those 4 equations into the spreadsheet. All right, and so what we're going to do, the reason that I scope it out this way first, the reason I write it down like this, is because this is the way that I'm going to, if I'm approaching this problem in the real world, what I'm going to do is I'm going to have to write this down, you know, in my own shorthand or in sentences or something, you know, as a series of steps, just so that I can have something to refer to while I'm building my spreadsheet. If I think it through and it works and it makes sense on paper or in a Word document, you know, ahead of time, then when I go to build my spreadsheet, I'm going to build a nice, clean, straightforward spreadsheet. Okay. If I'm trying to figure this spreadsheet out on the fly, sometimes you have to do that. But if that's, you know, the way that I do every spreadsheet, you're going to have problems. Okay. You're going to run into issues, and it makes sense to think out the problem all the way through, or as far ahead as you can, ahead of time before you start tinkering. So once we understand the steps that we need to go through, we're going to set up our spreadsheet. Okay. And the assignment here, the exercise, gives you a number of bullet points that say, okay, these are the terms that we know we're going to need because we did this math ahead of time. We know we're going to need the volume of sediment, the bulk density of the sediment. We're going to need mass. We're going to need a conversion from pounds to kilograms, etc. And so what you'll see then in figure 1 is you'll get all the way out here to mass. You'll get out to column J, phosphorus mass in pounds. Okay, when you set this up. And don't worry about removal A, B, C, D yet. Okay, when you start to set this up, you're just going to end up with this right here. You're going to end up with A through J. And, you know, at that point, you can start filling in the things that you already know. Okay, we already know that the volume of sediment per the report is 7,300 pounds or there. 7,300 cubic yards or thereabout, and the bulk density is about 1,173 pounds per cubic yard. Okay, and then we go all the way over to the phosphorus concentration in grams per kilogram because that was given to us in the report. And we know it's 2.63 grams of phosphorus per kilogram of sediment. Okay. So this is our situation in figure 2 of the document. The next thing that we can fill in here before we have to do anything special is the conversions. Okay. And we can go to Google and we can look up the conversions. There are also conversions built into Excel that you can use, but you can also use Google. I prefer to use Google and just look up kilogram to pound or pound to kilogram conversion. It's really straightforward. Google makes this very easy. And you can see straight away that we've got a pound to kilogram conversion of 0.45. This text is small, 3592. Okay. Make sure that you get it going the right way. You don't want a conversion that goes from kilograms to pounds if what you really need is pounds to kilograms. Okay. So just make sure that you're moving in the right direction whenever you're putting in a conversion. And if your math is not making sense at the end, if things don't seem to be adding up properly, when you do a kind of gut check, like the reason is almost certainly because, well, maybe not almost certainly, but take a look at your conversions. Okay. Take a look at your unit conversions because there's a good chance that that got worked in the wrong way. Okay. So when we convert grams to pounds, it's going to be really small. Okay. Because there's not a lot of pounds in a gram and there's lots of grams in a pound. Okay. So we're going to go with 0.00220462. Now, if I was being really, really strict, I would say, okay, you only actually get a certain number of significant figures here. In this case, maybe we're only going to go with 3 significant figures. All right. Or we're only going to go with, out to the 100th place or something like that. Because we're only given 2.63. There's a big deal that's made in high school science classes about significant figures, or at least there used to be. And there's I got a little bit of significant figures lecturing in college, in undergrad. But once I was in my 3rd or 4th year of undergrad, and once I was in grad school, like nobody cares about significant figures. I mean, if you're in a lab environment and you need to accurately reflect the precision of your instruments, then absolutely significant figures matters a lot. Okay. But if you're not working in a lab and using these kinds of instruments, like for unit conversions, as many decimals, like just cover all your bases. Okay. Because I know I've got some really big numbers over here in the thousands, like if I just put 0.5, if I said it was the conversion was 0.5, I'm going to be off by a lot. Okay. Because I'm multiplying by a really big number. And so I want to go many decimals out in order to ensure that I'm getting accuracy in my conversions. All right. So now that we've got all the information that's sort of a gimme, it's from the report. Okay. And then we go to Google and we get this stuff. Like, how are we gonna do the rest of this spreadsheet? Okay, like how are we gonna actually tell the spreadsheet, give me the sediment mass? And the way you tell a spreadsheet to do calculations, I described this in the document in some detail, and you really should read it because it makes things really obvious. What I'm about to do, and it explains why I do what I'm about to do. But essentially, what you have to do to tell a spreadsheet to do a calculation is you put an equal sign. That's the starting point. That's telling the spreadsheet, hey, this cell, each of these little squares is called a cell in spreadsheet land. So this cell located at D2, okay, like we're playing Battleship, all right. Column D, row 2, this cell, D2, all right, we need it to equal something. Okay, I'm going to put something after this equal sign, and whatever that math works out to be, that's what this cell is equal to. That's what you're going to show the world in this cell. That's what it's going to That's what the expression or the function is going to output. Okay, is going to be whatever I say is to the right of this equal sign. So, sometimes my habit is to write with the math, the thing that I want it to do. If it's arithmetic, you just use you just use sum, and from that point you can start to do any number of things. You can say 5 times 12, and it'll give you 60. Okay, you can also do equals 5 times 12, and it'll give you 60. All right, so some people feel like the sum is just useless and it doesn't need to be there. It's a habit of mine. Strictly speaking, it doesn't have to be there in a lot of cases, but I like to put it there because I'm weird. But you're not going to put it there as you're building this spreadsheet. All right, at least in this instance. The thing that really makes sum useful is if I'm adding up multiple columns. Okay, if I left click here on sediment volume and bulk density, and I want those two things to be added together, boom, then I can add them together. We're not going to do that. That makes no sense in this example, but that's how you can use the sum expression. And you'll note when I type in sum, I then have to do an open parentheses and a close parentheses. And so whatever's inside those parentheses is what Excel is going to sum. That's what the spreadsheet is going to perform the sum operation on. Okay. And I'm going to tell it, all right, go to cell B2 through C2. That's what the colon means there. B2 through C2, right? Inclusive, and sum that up. All right. So that's basically how sum works. In this instance, what do I want to do to cell B2 and cell C2? Well, going back to how I set the problem up, I want to take the volume of sediment in cubic yards and multiply it by the bulk density, which is given in mass of sediment in pounds divided by the volume of sediment in cubic yards. And what do you know? Because we set the spreadsheet up intelligently, we have B right here, which is the sediment volume, and we have the bulk density right next to it. And so we can just multiply these two things together. And that's going to give us our mass. Okay, that's going to give us our total pounds of sediment. It's very large, right? It's quite substantial because recall, we've got a, and that makes sense because we're in a situation where we have 7,000 cubic yards, and each cubic yard is over 1,000 pounds. All right, so here we are ending up at about 8.6 million pounds of sediment. Okay, so the way that you go forward from here is it's pretty much exactly the same thing, because remember, we've set this up intelligently, we've thought ahead, we've planned ahead, and so all we're going to do is multiply sediment mass by the unit conversion, and that's going to give us the sediment mass in kilograms. Okay, we're going to go from pounds to kilograms here, so we're going to do the same thing. We're going to do equals cell D2 times cell E2, and we're going to get a little bit less than half. Okay, because this is a little bit less than half. There you go. And now we have sediment mass in kilograms. And that sets us right up, because now we can calculate the mass of phosphorus based on the phosphorus concentration in grams per kilogram that was given to us in the report. So we're just going to do the exact same thing. We're going to multiply cell F2 by cell G2, and we're going to get a mass in grams. And the reason it came up with those numbers, that number sign first, or the hashtag first, is because this column wasn't wide enough. So if you ever get in a situation where you're just getting these hashtags or these number symbols, make your column a little wider, and a real number will actually hopefully show up. Now I want to make the point that even though this cell right here, cell F2, is an expression, it doesn't actually, I didn't put any numbers here. I didn't say, F2 is, as I'm going to do here in F3, 3900025, right? That number isn't what's entered in the cell. But what Excel, what the spreadsheet is doing is it says, oh, I know what's going on. You've got an expression here that outputs a number, an actual number, and then you want to use that cell. You want to use F2, which is just an expression. I didn't give it a number. I gave it an expression. You want to use that expression as part of this next expression. Okay. Well, it's going to go ahead and use the number that's showing up here. It's going to use 3900025. Okay. Just under 4 million in the math, in the arithmetic. All right. And it's going to then go give me 10 million. Okay. And then we're doing the same thing. We're converting grams to pounds. And that's all she wrote. Okay. So now, what do you know? We have our pounds of phosphorus. Okay. 22,613 pounds of phosphorus were removed by this project. You say, great. That's awesome. But why did I have to do this in a spreadsheet? I could have just done that with my calculator. Well, the reason you want to do it with your spreadsheet is because your boss is going to walk up to you and say, hey, I've got 3 more projects, or I've got 30 more projects, or 300. Okay. So you don't want to do that 300 times on your calculator, right? You want the spreadsheet to automatically do it all for you. So what are you going to do? You're going to go and look at table 2. Your boss gives you, these projects, says, all right, this is the volume of sediment. This is the bulk density. This is the phosphorus concentration. All right, cool. Oh, and then we need to, convert it over into this like weird thing called credits and divide by, 1.5, and that'll give us the number of credits. Okay, sure. But let's focus on just getting to the mass of phosphorus for these other removal projects. Okay. So project removal B took out 2,340 cubic yards of sediment. C took out 5,680, and D removed 10,050. All right, very nice. Now we've got those all entered in our spreadsheet. Very good. Do the same thing for bulk density. 1345, 1032, 989. Very good. All right, fancy. Now we've got our bulk densities. And then we can go and look at the phosphorus concentration. Okay, 4.16, 3.02, and 1.10. Okay. So one of the things you'll notice is sometimes what Excel wants to do is it wants to cut this off. It wants to make this look like 1.1 instead of 1.10. And in order to be strictly correct, in order to accurately represent the precision of the measurements that were taken, you want that 0 there, right? Because that's what was given to you in the report. That's communicating to you that we know to the 100th place what the value is of this variable, of this phosphorus concentration. And so, if you go into format cells, sometimes what Excel will do is it'll, this number here, this decimal places, like if I go to general, it'll just be 1.1. It'll drop the 0. Okay. If I go to number, I can tell it, hey, give me 3 decimal places, or only give me 1. In this case, I want 2. And I can also tell it to use the thousands separator. Okay. Which is what I've done in these cells here. I've said, I don't want decimals. We don't need decimals in these cells, but I do want the thousands separator, because when I start looking at numbers bigger than 100,000 or 10,000 even, I really like to have the 1,000 separator. It makes it a lot easier to understand the number. Okay. So with that note aside, here we are. We're in the same place, okay, as we were with removal project A. So what we could do is just emulate the exact same thing. This equals that times that. And we could go and do 0.453592. We could enter this all by hand again. Okay. But that sucks. No one wants to do that. That's a huge waste of time, especially if you've got removal projects that go like all the way down. You've got like 300 removal projects, huge pain. You don't want to do that. So what do? You've already had to enter this stuff by hand. That's kind of unavoidable. All right. So what are you going to do? Well, Excel and other spreadsheet software have this nifty thing where you can cut and paste, and you can cut and paste not just one cell at a time, you know, Control C, Control V, Control V, Control V. No, you don't have to do that. You can tell it to cut and paste without doing Control C and Control V, or copy paste, whatever, just by clicking on this little dot, this little solid box here in the bottom right corner. Let me see if I can make this bigger. This little box in the bottom right corner of any cell you select. And what that'll do is automatically populate every cell below that until Excel thinks that you're done, that you don't need to populate below that. And if I just double click that, it goes all the way down to where Excel thinks I'm done. Okay. And so it did that with a conversion. That's great. I know what that is. I know, you know, the number doesn't change, right? A conversion is a conversion is a conversion. I'm not changing that for each observation, right? For each project, the conversion, the unit conversions stay exactly the same. But of course, all these other things that have expressions in them, they might change. They're going to change because we're using different numbers. If there's a different sediment volume and a different bulk density, then we're going to get a different mass. And if I just do a regular cut and paste, okay, or copy paste, you might think, well, it's just going to copy B2 equals C2. And your next one is going to be exactly the same as the one above it because it copied B2 times C2. You have to actually do that manually in Excel and other spreadsheet software because that's such a weird thing to do. Typically, you just want to multiply, you know, in this case, these two numbers that are right next to this cell, this target cell. So what's going to happen is when I copy, even if I do Control C, Control V, it's going to come up with a different number because what it's doing, if you look at the formula bar, if you look at the expression, it's now referring to these two other cells right next to it. So what Excel and other software does is it refers relative to the target cell. So what's actually happening in the background is Excel isn't saying, hey, take B2 and multiply by C2. In the background, what it's saying is, hey, take the cell that's two to the left, two columns to the left in the same row and multiply it by the cell that's one column to the left and in the same row. Okay. And when I copy and paste that all the way down or double click the box in the bottom right-hand corner of the cell, it automatically populates. It does so essentially instantly. And I can do that for all of these. Ignore that. And I'm done. It's over. We just got handed 3 more reports. And because we have a good spreadsheet set up, boom, it's done. It's over. It took us less than a minute. Okay. Took us a little bit long, you know, a while to set up that initial spreadsheet, but at the end of the day, we got 4 of these reports done in the blink of an eye. And if you had 300 reports, you better bet being able to double click on this and get it all the way down to 300 reports automatically is going to save you a ton of time, okay? So that's the basics. Like that is really like the basics of how spreadsheets work. I didn't throw in any division. I mentioned addition and subtraction and so forth, but it's all the same. Okay. If I wanted to know what's the difference between the mass of sediment in project A and project B, all I got to do is click on this number, subtract that number from it, and then I can know that answer, about 5.5 million. Okay. If I want to know, how many times this bigger, removal project A was from removal project B, I just use the division. Just use the division symbol, just turn it into a fraction. And it's going to give me 3. And I'm going to go, that's weird. And the reason that it's giving me 3, of course, is the cell formatting. So if I say, actually, give me more decimal places, now it makes sense. Okay. So sometimes you'll get a number that like doesn't make sense. Also check the cell formatting. Okay. Check your unit conversions, check your cell formatting. And so here we are. We just moved like all the way out to figure 12. Very cool. So then there's a couple things that we can do from here. Okay. One of the things that we're going to do from here, first of all, is calculate the total phosphorus that's been removed by all the projects cumulatively. Okay, so assuming that, removal A, B, C, D are in chronological order, over time, we might want to know how much total phosphorus has been removed. So how are you going to do this? You're going to use expressions, and you're going to use equal signs, equals something. You're going to use those, and you're going to use the fact that you can refer to other cells in your expressions. So total phosphorus removed. Well, that should be easy. 22613. Okay. This is a little bit harder. This equals 22613 plus 13093, right? Okay. I got a number here. It's the right number, but that was a dumb way of doing it. That was a really time-consuming way of doing it. That's not extensible. Extendable. If I have 300 projects that I need to keep track of, it doesn't make a lot of sense to just go in there and be like, okay, 22613 plus 13093 plus 17702, right? I'm getting the right answer, but it's a huge pain. And you can start to see how this formula in the formula bar, if we had 300 of these, it would become unmanageable. Okay, so we're not going to do it that way. What we're going to do is we're just going to say cell K2 is going to equal cell J2. Okay, this is just the way I do it. It's just, I think of it as good practice. All right, because as this number changes, say I get an addendum to this first report, removal A, and it says, hey, turns out that the sediment volume that was removed, we actually miscounted a couple of the dump trucks. It was actually 7540. Okay, well, now what's going to happen is all of my numbers are going to change. My mass changed, okay, in pounds and in kilograms. All right, my mass of phosphorus therefore changes. Okay, and now over here, my total phosphorus will also change. If I didn't do it that way, and I just said, yeah, this is 22613. Well, if I have to change this, okay, now it's wrong. All right. So the whole point of a spreadsheet is that you get to be like really, really flexible. All right. This isn't just a calculator, although it is in the background. It's a really awesome calculator because you can tell it, hey, refer to this cell. If this ever changes, update this expression, update the output of this function, make this cell something different. So I'm just going to say, hey, cell K2 equals cell J2. And now for cumulative, for the total amount of phosphorus that's been removed here so far, once I'm done with project B, what I'm going to do is rather than saying, oh, this equals the sum of this cell and this cell, because what happens if I go to, okay, sum of this cell and that cell, okay, sum of all those cells, that's, I have to, every time I go do a new project, I got to come down and do this. Huge pain in the ass. You don't want to do that. Okay. What you want to do is have as few terms in your expression as possible. Keep it really simple. Okay. I want to take the cell that's right above it, which has the cumulative amount of phosphorus removed so far. And I just want to add the next project's total phosphorus. Okay. And now when I double click on this box, it's going to do that math for, right, the one above plus the one to the left. It's going to do that exact same thing all the way down. Okay. And so, you know, something as simple as changing the phosphorus concentration, 2.65. Now all the numbers are going to change. They're going to update automatically. Okay. Really, really nifty thing about spreadsheets. Okay. This fact that you can refer relatively, you can refer to other cells. All right. Now, one of the consequences of this is that if I go and just do, hey, Excel, copy this cell here, copy K, K5, and paste it into the cell below, K6. Oh, it's the same number. Oh, that's cool. Oh, it's the same number. That's cool. Same number. That's cool. Why is it the same number? It's not the same number because it's pasting 64342 into the cells below. Okay, that's a hint. It's pasting the expression. It's saying, hey, give me the cell above plus the cell to the left. And since the cells to the left are empty, the same number comes out. But if the cells to the left weren't empty, if they were something different, these numbers would keep updating, right? Etc. So this is something that you have to understand about spreadsheets. When you copy, okay, you are copying the expression. All right. And you're copying the expression relative to the cell that you're copying. You're not copying strictly K4 plus J5. That's not what you're actually copying. You're copying cell above plus cell to the left. Okay. If you want to copy K4 plus J5, you actually have to click into this formula bar, copy that text, and then paste into the next cell. Okay. Because if I copy and paste here and here and here, right, I'm going to get that cell plus that cell and so forth. I'm not going to get the exact same number. Okay. Because it's relative. I'm going to get something a little bit different. All right. Credits. The next thing that your boss wants is credits. All right. How many credits? Oh, well, okay. One of the things that you can do here, just to make sure you did the math right, is use the sum expression. So because sum of J2 through J5 is the same number as you got here doing this above and to the left, you know you've did your above and to the left correctly. Okay. So for credits here, all we're going to do is recognize that somewhere in this document it says that you have to divide these the pounds of phosphorus by 1.5. That basically the number of credits that is awarded for removing a pound of phosphorus is not actually a whole credit. It's less. You get less than a whole credit for removing a pound of phosphorus. And that conversion factor is 1.5. So all we do is we say, hey, refer to the cell to the left and divide by 1.5. Do that for all of them. Okay. And oh, okay. So what I did here is I took the credits, and instead of doing credits, I told it to do total credits actually. So this is a great way to make a mistake. One of the problems with the way that this spreadsheet is set up, and maybe it's not a problem, but it's something you need to pay attention to, is here I've got mass in pounds of phosphorus for each project individually, and here I have a running cumulative sum, okay, of phosphorus. And the reason these are right next to each other is because they're both phosphorus. And the reason these are both next to each other is because they're both credits. But one of the ways that you could also organize this spreadsheet is to have the total phosphorus removed and the total credits be at the very end of the spreadsheet. Okay, you could have it look like this. And this is what happens when you break an expression. Okay. So it's what it's saying is, hey, that cell doesn't exist anymore. There's a reference error. Okay. So total phosphorus removed equals that. But now I want to add this cell way over here. I don't want to add the cell right here because that's mixing and match. That's mixing in the wrong units. Here I've got credits. Here I've got the mass of phosphorus. So I want to go and skip a row. Sorry, skip a column. Right? And there we are. And so if I just want to calculate credits, divide by 1.5 for each project, now I've got the credits for each project. And then what's kind of handy here is that, this cell refers to the one above it and 2 rows to the left. Well, guess what? That's exactly what I want here. I want this cell to refer to the one above it and 2 columns to the left. So here we go. Now I've got a running total of credits. And just to make sure I did it right, I'm going to take the sum of all the pounds and I'm going to divide by 1.5. And what do you know? It's the same number. Okay. So now we have our total credits. We have a running total of credits, a running total of pounds of phosphorus removed. Okay. We have the pounds of phosphorus for each project and the number of credits for each project. And we're basically done. Okay. Until we get to section 6. And now our boss wants us to do a little bit of analysis. They want us to do some statistics, some really basic descriptive statistics. Remembering back to the lecture that I gave on statistics, or the portion of the lecture that was on statistics, you'll recall that descriptive statistics just tell you about your data. They don't test a hypothesis. They just say, hey, this is like the average. This is, the spread of the data, the standard deviation. This is the maximum and the minimum. Okay. It's that kind of stuff. All right. So let's calculate some of that. All right. And we're going to push through. We're not going to have a break today. We are going to be done in like 15 minutes or so. So we're not going to have a break. And once we're done, we're done. I'll stick around for questions, but otherwise, quick lecture. Before I go on and start talking about descriptive statistics, are there any questions about what I've done so far, the spreadsheet that's in front of us, how this all, maybe not a question as broad as how this all works, but anything that's happened so far that is you're really scratching your head and you want me to address.
I don't think so. I don't have any questions.
Awesome. Okay, great. Well, if you do have a question, yeah.
I have a quick question. On the Word document, you have L as credits, but on your document that you've been working on, you have credits as K. Do you want us to switch that when we do it?
I'm not that concerned about that. You know, I switched it right here because I wanted to illustrate the different way you could organize this.
Okay.
Yeah, so it's not that big of a deal.
Okay, thank you.
Yep. Very cool. All right. So the next thing that my boss wanted to know, more or less, was, you know, tell me about this program overall. Like, tell me about these projects. Like, summarize some of the stuff about these projects. Well, to do that, you know, the minimum, the maximum, and the average. Okay. And she wants minimum, maximum, and average in kilograms of sediment mass and phosphorus concentration and in credits. Okay. So you'll recall that, you know, this is a calculated value. Phosphorus concentration here is not a calculated value. So that's something that was given to us in the report, right? The report said that phosphorus concentration was 2.63 and 4.16 and 3.02, et cetera. But what if you get that addendum? What if you get the report that comes back and says, hey, actually, we screwed up. We forgot about this other sample in the lab. When we ran that sample, it changed the phosphorus concentration from 2.63 to 2.65. I don't want to have to go through the report and, like, you know, repeat that. Okay. I don't want to have to go through the report. And every time it says phosphorus concentration for project A, 2.65. Okay. I got to change all of them to 2.65 because you may have like multiple spreadsheets. You may have multiple, you know, tabs in your spreadsheets. Okay. Where, where this appears, and you might only want to have to change it once. And so this is jumping a little bit ahead. We don't actually talk about this in this document. We talk about it in the next exercise, next spreadsheet exercise. But I'm gonna show it to you now. Just be aware that you can, if you want, do 2.63, 4.16, 3.02, 1.10. You can do that. You can enter it by hand, no problem. Okay, but you already did that on the other sheet. So what we're gonna do is we're gonna select this cell, phosphorus concentration. Okay, we're gonna select the cell, left clicking on it, and then we're gonna left click over into the first sheet. Well, no, first what we're gonna do, sorry, is do the equal sign. We're gonna make an expression. Okay, we're gonna tell Excel, we're gonna tell the software, hey, I'm about to do something. I'm about to like enter some numbers or click on a cell, and I want you to put that in the expression. Okay, so we can click over then to the first sheet. We can say phosphorus concentration of project, removal project A, and just left click on it. And you'll notice in your formula bar up here, the expression that you've just generated is equals sheet 1, cell G2. And if I press return, it's going to take me right back to sheet number 2, and it's going to include the value of cell G2 from sheet 1. And if I go back and I change cell G2 to 2.65, what do you know? It changes it on this sheet as well. Okay, so I can also double click on this bottom right box, and it's going to refer now to the cells below G2 on the previous sheet. It's going to refer to G3 or G4 or G5. Okay. So it functions the exact same way when you double click this box. It's saying, hey, I'm the target cell right here. I'm cell C3. Make me equal to that other sheet, the cell that's below, G2. Oh, that's G3. Cool. Yeah. Make me equal to G3. All right. Sediment mass, same thing. Equal sign. Click over to sediment mass. Left click, press return, and there we go. Oh, I screwed up. Okay. This is why your units are really important, because this is sediment mass in kilograms, right? It's what your boss wants. So it's not cell D2. Delete that. Okay. Wants it in kilograms. It's cell F2. Jeez. You press enter, and there you go. Double click on it. Now we filled in sediment mass. Okay, here and here. Same numbers. Credits, we can do the exact same thing. Equals. Click on the credits. And there we go. Okay, so that takes us through figure 17 in the sheet. All right. Now in the document, I do run you through paste special. Paste special is basically going here, saying Command or Control C, going to here, right clicking, paste special, and saying, I want only the values. I don't want the formulas or, the expressions. I don't want you to copy over any formatting. I don't want you to copy any comments that someone has made on the spreadsheet. I don't want you to copy the column widths or anything like that. I just want you to copy the values. And I don't want you to add or subtract or do anything like that. Okay, I just want the values. I just want the numbers, the outputs of the expressions. Okay, and then it gives you those outputs. It gives them to you as numbers, not as expressions. Okay, so if something changes over here because we only pasted values and we didn't paste formulas or expressions or anything like that, then we end up with a situation where these don't change. Okay, so I like it when things do change in the real world. If something actually changes, I want my spreadsheet to be able to be updated live to reflect that. So we're going to leave it as it is here. And now, in order to calculate the minimum and the maximum and everything else, we're just going to use some formulas. Okay. Some built-in expressions that Excel has, or that Numbers has, or that Google Sheets has, or that LibreOffice has. Those are the 4 software tools I know of and have used for spreadsheets. To do mean, it's a little strange because although mean is the arithmetically correct term for an average, what we think of when we say average, Excel doesn't use mean, it uses average. So to get the average of the sediment mass for each project, we just type in average, open the parentheses, left click on the top cell, drag down to the bottom cell, and release our left click. Now it's got this range, B2 through B5. Okay, I close the parentheses, and what do you know? There it is, the average sediment mass in kilograms removed by these projects. And again, you could go and bust out your calculator and do this on your own. You You could even hard code this in. You could even be like equals sum, this one plus this one plus this one plus this one, all divided by 4. And you get the same number. Okay. So the reason that we're not doing it that way is because average is really easy. It's really straightforward. Probably at some point people were going through and they were doing this one plus this one plus this one plus this one divided by 4. And it got really tedious and boring because if you have 300 of these, you don't want to do it. You just do average and it's built in. That's what's going on in the background. It's adding this all up and dividing by the number of observations. That's how you get the average. So now we have sediment mass. And the great thing is, because it's referring to this range, if I want the average of the phosphorus concentration, I just copy and paste. Okay. And then I go in and I say, hey, give me some decimal places. And there you go. Same thing with credits. Copy and paste. You go, hey, you know what? I actually don't want the decimal places for credits because credits only come in whole numbers. Well, there you go. Now we've got our average sediment mass, got our average phosphorus concentration, and our average number of credits for these 4 projects. Okay. And min and max are essentially the exact same thing. I just do equals min. Boom. Same deal. Okay. Same deal. Now, if I copy this whole row and paste it, I get minimums, right? But here's the thing. The numbers, even though I'm supposed to get maximums, I've told it, hey, use the minimum function. Notice the range. The range moved down 1 because the target cell moved down 1. And the only reason the numbers are the same is because it just so happens that the minimum is still in the range. Okay. So this is something to be aware of, is if I copy and paste, remember, the references change. It's relative to the target cell. All right. So what I really want here is maximums. Okay, I want that range. It's going to give me the maximum now of everything. And there we are. Okay. So this is one of those things where if you didn't know how to get it to tell you the minimum, you just Google minimum in Excel, maximum in Excel, and the world will reveal itself. That is like the secret of doing this kind of work, whether it's in Excel or in R or Python or any kind of statistics software, any kind of computery thing. If you don't know how to do it, yeah, there's like help functions inside here. Like if I go equals max or equals M or equals MA, it'll give me all the functions that start with M. And then I can click on it and say, oh, match. That's cool. What does match do? And it'll give me these links below match. And I'll click on match and it opens the Excel help file. Now I can read through, oh, what does it do? I can even watch a nice video.
Need to see the exact or closest position of a value in a row, column, or table in Excel?
Well, this will tell you. This will tell you how to do it. Okay. So you can use Microsoft's help box here. They've got some examples. They've got some functions that also do similar things. You can tell them their information was not helpful or helpful. The idea here is you can use what's internal to the software, the help within the software, or you can say, hey, Google, like I want the minimum. What's the minimum? How do I get the minimum in Excel? And Google will be sure to give you the answer. Several answers, some of which will be wrong, but most of which will be correct in their own unique, special way. So that's spreadsheets. That's the really basic intro to spreadsheets. That's kind of how they behave. All right. Those are some of the things, really basic things you can do with them. I really want to emphasize that spreadsheet expressions or formulas are relative to the target cell. That is such a critical thing to take away from this exercise, is that when you're copying and pasting, not the exact expression. When you're referring to other cells, you're copying and pasting the relative position of those cells to the target cell. Okay. You're not copying and pasting, cell C2 plus, cell D2. You're copying and pasting the cell that's two columns to my left, plus the cell that's one column to my left. Okay. That's what you're copying and pasting. You're not copying and pasting the exact formula, let alone the number that comes out of the formula. Okay. So just be aware of that stuff. This double clicking on the bottom left box here is super, super valuable. Okay. It's going to save you a ton of time. And referring to these cells is going to save you a ton of time, as opposed to just hard coding everything in. Hard code in what's given to you in the report, the stuff that you can't calculate, the stuff that's a given value, your conversions and so forth. Everything else calculated in the spreadsheet, and refer to those cells that do the calculations so that your spreadsheet updates in real time dynamically. Bulk density changes, if the sediment volume changes, etc. You want to be able to make that change in one location in your spreadsheet and have it work its way through the whole thing. Okay. Are there any questions about these very basic descriptive statistics and all that? Okay. Well, great. That's cool. Yeah, there wasn't really anything new necessarily. It was all just now we know minimum and maximum and average. Okay. Well, Jessica, I know that these are not your favorite thing in the world. Hopefully this, was useful. And I hope that if you ever have to use spreadsheets again in your life, that, what we've discussed here maybe demystified some of it and maybe was a little helpful. And certainly in this class, I'll ask you to use it at least 2 more times.